Okay, let's start. Bismillahirrahmanirrahim. So we are studying uh, the course that is data communications in computer networks. So we are continuing chapter number 1 from top-down approach, computer networking, a top-down approach. So 7th edition. If you do remember, so in the last class we had discussed network core, and in more particularly we discussed two types of approaches that are used to deliver the data across the core networking. So these two approaches are circuit switching and packet switching. So we have discussed circuit switching and packet switching through examples. Okay. So in today's class we are going to continue chapter number 1, and we are continuing network core, but now we are discussing network core from another perspective, that is for internet service provider, that is from provider perspective. Okay. So we will discuss the network core. So more specifically we are going to discuss Isps, internet service provider, and how the Isps are interconnected with each other, and then we will discuss end-to-end delay. Okay. So this is the overview of chapter number 1. Okay. So if you do remember, so we had discussed that the internet structure, it can be divided into two parts. One is called access network or network edge. So this is the network, and this is connected to the first router of the internet. So this is the edge network, like this one, this one, this one. Okay. And this is the core network. The core network, it is basically the interconnection of the routers, and this core network, it basically connects the edge networks with each other, So we had discussed two approaches for moving the data across the core network. So these two approaches are circuit switching and packet switching. So in today's class we are going to discuss that who deploy this core network, because there will be someone who deploy this core network across the world globally. Okay. So for example, in Pakistan we have mobile phones companies. Okay. For example, Ufone provides the mobile connectivity in the Pakistan. Similarly, Zong also provide. Okay, so there may be some regions where Ufone and Zong, they are both providing the mobile connectivity, the cellular networking. So the user, so how they are connected with each other. So this is the Zong and mobile. For example, if someone wants to call from Ufone to a user in Zong, so there must, so the Ufone and Zong, they are connected with each other. Okay. So similarly, if a user is, so there are multiple ISPs, and how these ISPs are connected, and these ISPs should be connected with each other. Why? Because if a user from one ISP wants to call a user in another ISP, so there should be. Okay. So that's why and there should be some areas where only Ufone users are available, Ufone provider is available, but there are some areas where only Zong providers is available. So there should be must connectivity. So in the similar way, the internet ISP, the core network that is deployed in the world, they are connected in the same way. There are multiple ISPs, and these multiple ISPs are connected with each other. So now we are going to discuss this perspective of the core network. Okay. So basically, if you look internet, so we have end systems, and the end system they are connected to the internet via access ISP. So we have discussed different access network technology like DSL, cable, Wi-Fi, 3G, 4G, etc. For example, in the DSL, for example, we discussed PTCL is providing DSL connectivity. Okay, in Pakistan. So these access ISP they must be connected with each other. Why? Because if one access ISP, for example, this one, it wants, for example, the PTCL in the Pakistan, it for example, one is connected through DSL. For example, one is connected through DSL, and the DSL is provided through PTCL, and one person is connected through 3G. Okay, for example, through UPhone, suppose in Pakistan. So if a user from the DSL wants to call to send data to a user that is connected through the UPhone through 3G, so they must, so the PTCL ISP it must be connected with the UPhone ISP. Okay, so they must be connected so that any house, any two house belonging to different ISP, they can send data to each other. Okay, so similarly the user from in the PTCL, for example, the PTCL is providing connectivity in the Pakistan, so a user is connected through DSL to the PTCL ISP, and the user is calling to a user in the US. So in the US the PTCL is not available, there will be must another provider. And how the Pakistan is connected to the USP to the US, there may be another provider. Okay, so the connectivity of among different ISP, it is basically it is a complex networking. It is a complex networking, and it is also another research area, and it is a different domain. Okay, but overall this connectivity it is driven by economics and national policies. Economic means that if there is a there are providers that connects Pakistan with the US. Okay, but there are different options available, so each one has to charge you, so they may have different charges. Okay, for example, it can be like roads and transportation system. For example, if you want to move from Islamabad to Karachi, so we have different transportation system. For example, you can move through Davo service, you can move through Bilal coach, you can go through PIA, you can go through Blue Air. Okay, so these are different, so and each charge you differently, and they provide, that depends upon the services. Okay, so similarly the ISPs that are connected with each other, they also charge you, and they have different services, they have different rates, charging rates. And similarly there are some policies. For example, in Pakistan the PIA is operating, okay, and the Blue Area is operating, but the Emirates it doesn't provide services from Islamabad to Karachi. The Emirates it may provide the services from Islamabad to Qatar to Dubai, etc., but it doesn't provide from the Islamabad to Karachi. So similarly, so it depends that whether their infrastructure is available or not. Okay, so to discuss their connectivity of the ISPs, so let's take a stepwise approach. So we are going to discuss from very basic that how these ISPs connectivity are evolved, and they have to be evolved. Okay, so I think it is up to now you should you will have some kind of overview of a concept of ISP. Okay, so suppose that we have access networks. For example, here the ComSet WAC campus is connected through to an access ISP, access network. These are access networks. Okay, now if one access network is wants to send data to another access network, so these access network, they should be connected to each other. Okay, so how they can be connected to each other? So let's take the first option is that this is the first option. In the first option, each access ISP, it is connected to every another access ISP in the world. For example, in Vacant, we have access ISP, and it will be connected to the access ISP not only in the Pakistan but also worldwide. For example, in US, in India, in Bangladesh, in Saudi Arabia, etc., etc. So this is the one option, and this option is not workable. It is not feasible. It is even impossible. Because why? Because connecting CUIWA to an ISP in the US, it is impossible to lay down the wires, the cables, the connectivity, and so on. So it is impossible, and it creates a lot of links, and these links may sometimes passes through multiple countries. Okay, so definitely it is very, very expensive. Expensive means that it is somehow impossible. Okay, so we have another option, and that is called option 2. What is option 2? In option 2, suppose there is a global ISP, one ISP, and they deploy their routers. Okay, they are connected throughout the world. Okay, for example, they have deployed their routers throughout the world, and these routers are interconnected. Okay, so in each area, access network, they are connected to this global ISP. Okay, so if this access network is connected to this global ISP, and this access network is also connected to this global ISP, so the user of this access network can access the user of this access network. Okay, so the second option can be that we have a global ISP. Global ISP means that there is a provider ISP who have deployed their routers all over the world, and their routers are interconnected. So each access network is connected to the global ISP. So it means that each access network is connected to each and every access network. So it means that this global ISP, it is called transit ISP. Why? Because it is just working to move the data from one access network to another access network. Here the customer, so it is the customer ISP. Access network is customer ISP because it is needing the service of global ISP to send data to another access network. So this access network, they are the customer ISPs, and this global ISP, it is the provider ISPs. Again, this global ISP, it is not feasible. It is not viable. Why? Because it requires too much investment for a provider to deploy their routers, their connectivity throughout the world. Okay, it requires too much investment. Maybe there is no one who can afford it. Second, it will have full control. For example, this is deployed by Facebook, suppose. Okay, and Facebook is owned by US. So it means that the Facebook, it will have all control. If Pakistan have some clashes with the Facebook, so the Facebook can stop the internet connectivity of Pakistan. Okay, then Pakistan can do nothing. So full control, and there is no competitor. So okay, so the Facebook will charge the access network. How much they will charge? It is their wish. How much they want. Okay, for example, if there is only PIA service available in Pakistan, to move to go to other countries. So you don't have any option, so you must have to use the PIA. So how much they charge? So they have their own wishes. Okay. But if there are competitors, for example, there is PIA and there is Emirates, so then there will be competition. So each will try to provide more services, to provide the communication with the low cost. Okay, so if there is a low cost, so definitely the people will prefer to low cost and with the more services. So then there will be competition. Okay, so therefore there is no competitor and it will have full control. So this global ISP is also not a viable option. So option 2 is not workable. Okay, so what could be the option? The option could be like 3. There are multiple transit ISPs. This is called transit ISPs that connect the access network with each other. And these transit ISPs, they may be operating in different region. For example, this ISPA, it is operating in Asia. This is operating in America. This is operating in the Central Asia. Similarly, there will be someone who are operating in suppose in other parts of the world. Okay, so it is feasible. Okay, but how these transit ISP, they should be also connected, because if this access network wants to send data to this access network is connected to ISP A and this access network is connected to ISP C. So these ISP, they must be connected, otherwise the data from this access network cannot be sent to this access network. Okay, so how to connect these transit ISPs with each other? So we have different options. Okay, so if one so there are different options, and maybe in the same region there are multiple transit ISPs. For example, in Pakistan we have VTCL, for example in the Pakistan we have different mobile phone operator like Ufone, like Zong, like Warid, like Telenor. So when they are different available in the same region, so different, there is a competition. They will try to provide best services with the lowest cost, with the more features. Okay, then the user have the options. Okay, so it will provide competition. If the Ufone service is not providing good services, then the people will prefer to use the Telenor. Okay. So similarly, these global ISP, they should be connected. So how they are connected? Let's discuss it. The first option that could be is peering link. It could be peering link. What does it mean? That the transit ISP, they are connected with each other. For example, ISP A is connected with the ISP B and ISP C. ISP C is connected with ISP A and B and so on. Okay. And how they are connected? They are connected on different economic base. For example, ISP A is connected to ISP C, and they have agreement that they will send the data of the ISP. ISP A will guarantee that the ISP A will forward the data of ISP C to the access network. Similarly, in the return, the ISP C will forward the data of ISP A to their access network. So maybe they have some agreement on based on data. For example, if ISP A is forwarding the data of ISP C to the user, so it will charge 1 MB for 1 rupees. Similarly, ISP C will also charge ISP A to move the data of ISP A to access network connected to the ISP C. It may be charged for 1 MB or for 1 rupees and so on. So they have the agreements and they are connected with each other. Okay, so this is one possibility. Another possibility is that there is another provider that is called Internet Exchange Point. This is another provider, and this provider only connects these transit ISPs with each other. Okay, they have their own communication infrastructure, their own routers, and they are operating in different regions. And the different region they connect these transit ISPs with each other. This is called internet exchange point. This is another area of research. This is a total different core network. Okay. Similarly, there could be different provider ISP in the region. For example, this is a regional ISP. It connects different access network with each other. What will be its benefit? And this regional network is then connected to the different transit ISPs. And these transit ISPs are connected with each other as well as they are connected through the internet exchange point. Okay, so if this access network wants to send data to this access network, then it will go to regional network, and then the regional network will forward to the access network. Okay, so this data will not go to the transit ISPs, to these global ISPs, to these access internet exchange point. So it will reduce the delay and it will reduce the cost. It will reduce the cost. Why? Because if this data has to go through this ISPs and then it comes to this access network, then it will cost more. But this regional network, it will cost less because it is already connected with this one. Okay. Similarly, in the internet, there are some companies, for example, Google, Microsoft, Academy, and they have deployed their own network in the world. This is called content provider network. They have deployed their own network, their own routers throughout the world to connect their data center, their servers with the rest to the users. For example, you are accessing a Google server. So the Google is Google search engine, Gmail. So their servers, they are the data centers. So they deploy in the worldwide their own routers and to connect their servers to the users. But this content provider network, it should be connected to the internet. Why? Because the people, they access this Google network through the access network, through ISPs. Okay, so how they are connected? So let's discuss it. So basically, if you can see, so there are different layers of ISPs. For example, this is access ISP where the user is directly connected to the internet. And this access ISP, they are connected to the regional ISPs and to the tier 1 ISPs. That is the transit ISPs. And these ISPs, they are connected with each other through internet exchange point, or they may be connected directly with each other. For example, this tier 1 ISP is connected to the regional ISP through the peer link. Okay, and it is also connected, the tier 1 ISP is connected to the internet exchange point. And this internet exchange point is connected to the Google, to the regional ISPs, and so on. Okay, so this is the network. So the Google, when they deploy their own content provider networks, so they usually try to connect their data, their network, their Google network, the content provider network, to the regional ISPs. So what will be its benefit? The benefit will be that, for example, this access ISP wants to access the Google. So it will go to access ISP, and the access ISP will go to regional ISPs. And the regional ISP is directly connected to the Google, so it will go directly to the Google. If it is not connected directly, then what will happen? Then access ISP will, for example, wants to access the Google. So it will connect to the regional ISP. The regional ISP will move the data to tier 1 ISP. So here the regional ISP is also charging, and here the tier 1 ISP is also charging. So it will increase the cost, and it will increase the delay, because access ISP is moving to the regional ISP. The regional ISP will move the data to the tier 1 ISP, and then tier 1 ISP will connect to the Google. So normally the Google is connected to the regional ISPs and access ISP. Even you can see that this access ISP is directly connected to the Google. So if the user wants to access the Google server, for example, if of this access ISP, so it will directly move to the Google. So it will reduce the cost as well as the delay. Okay, so this is the overall working of the internet structure, and you can see that this tier 1 ISP, there are different tier 1 commercial ISPs. For example, Sprint, AT&T, NTT. So there are different national and international level also ISPs. Okay, so the content provider network, it is basically a private network that is deployed by a big company like Google. Okay, and this content provider network, why? Because they have deployed their routers, they have deployed their own network, okay, to provide their services to the users closer. And how they do it, basically their network is connected to the regional ISPs and to the access ISP directly, so that the access ISP can directly access the Google server with the less delay and with the less cost. Okay, so I think it should be clear. Okay, so this is somehow figure that shows the distribution of the tier 1 ISPs of the Sprint that is provided by Sprint worldwide. Okay, so in the transit ISP, this is called point of presence. What does it mean? Point of presence. It is the basically in the ISP, it is a point where different ISPs are connected with each other. This is the transit ISP, and where different access network or different ISPs are connected with each other. Okay, so we have discussed the internet structure, the ISPs and their working. I think it should be clear. Okay, so I would suggest to you that you must have to study it in the book. Okay, so if you study it in the book, I think then it will be much clearer to you. Okay, so it is a very complex topic. Okay, the ISP, it is a very complex type network. Okay, so the ISP, the internet structure and their interconnection, it is a complex topic. I tried my best to explain it in the few words, but again I will emphasize that you must have to study it in the book. Okay, so in the next video we would like to discuss the in the next video we are going to discuss the another topic, and that is the delay loss and throughput in the network, that how the delay occurred, why the packet are lost, and what is the throughput. Okay, so in the next video we will discuss them.